Hello, everyone. Most of you know me. My name's Phil Winder, and part of the Bacalhau team. And me and Enrico are going to present a joint presentation. I've just been told that we've got a lot of time because the next speaker's not here. So I'm just going to take it easy, take it slow, enjoy it. We've split the talk into two sections, really. The first section is a bit of a technical brain dump of what we built, describing how it works, why we made the choices we made, and a few interesting stories around that and stuff. The second part is all Enrico's work, and he's going to talk about some actual use cases, do some actual demos, and show you all the cool stuff that can be done with said tool. So without further ado, welcome to Bacalhau Amplify. So I'm going to step back a little bit. I've been adding slides like during the past couple of days as people have been talking, because it's just kind of like spurred like thoughts and ideas. And this is a picture from the beautiful state of Wyoming in the US. It is like, you know, if God made the earth, like he had this little patch left that's called Wyoming, and he just put nothing in it. It used up all his good ideas, because there's literally nothing there apart from scenery. But what we can see in this picture, I don't know if you can quite see it. Can you see my mouse? Yeah. Over here is a tunnel, and there's actually a train line. And so there's quite a few sort of major train routes that go through Wyoming for historical reasons. It was on the old sort of discovery trails and stuff. But apart from that, there's nothing there. And the reason why I brought this up was because about 10 years ago, I worked with a piece of technology that basically was like an audio sensor. But if you imagine, it's not like a audio for like a single channel. It's like audio, but like over thousands and thousands of channels, which are kind of spread over vast distances, like 50 kilometers, 100 kilometers, vast distances. And the tech is really cool. So ask me about that later on, because it's quite an interesting piece of tech. But the point is that in this location, there's lots of data and no network communication, no nothing. It's the definition of an edge site, you know. And I came across this, and one of the ways that you can get access to this site is through good old telegraph wire. And I found this just earlier on. So the telegraph system grew with the extension of the railways, and it was because, like, in 1840, I think it was, nearly 1840, around there, Brunel built his first railway from London to wherever it was. And at that point, they didn't really have a good way of keeping time. So everyone was mostly still using sundials and using the sun to tell the time. And so depending on where you were in the UK, it was literally a different time. But the problem was, when they started with the railways, they kind of standardized on London time. But the problem was, like, Bath and Bristol and everywhere else was still using this slightly different time, which was 4 minutes out. So you had these timetables. This is a timetable from 1844 or something. And it's saying that, all of these times are in London time, but if you're in if you're in a different location, if you're in Bath or Bristol, then you need to subtract 11 minutes from all these times and subtract 18 minutes from all these times. And so then you got this definition of like Bath time and Bristol time, and it got very confusing for obvious reasons. So when the first telegraphs arrived, because they had these nice linear assets with land that they already owned, they just put telegraph poles like down through the railway lines, and that instantly fixed the time problem, because the first protocol was a time protocol to synchronize the train station clocks. So the point was, like, the first data cables were placed next to railways for that reason. And unfortunately, in locations like this, they still exist. And so that's the network. It's still using these 150-year-old copper wires that just go across the railway. And inside a little shed was a room like this. And this is where I did my work, and you can sort of see the screens with the data streaming down it there. This is like a visualization of that audio data. And the reason why we needed to do that was because on many of these trials. There were like proof of concept like trials, like can you use an audio sensor for detecting X? And these days you probably just remotely gather a load of data, train a model, and job done. But back then, you don't really know what to expect. You don't know what it sounds like. You don't know what it looks like. And the best detector known to man is man. So literally someone looking, like this. So it was like this. We had setups like this where we just had like 5, or this is one of my colleagues, like 8 laptops, and you just literally just scan across them because they're all sort of looking at different sections of the fiber. So that's kind of what that was the job. Sat in a shed that was over here, and these trials kind of involved lots of other things like driving tractors at night, and I've no idea how that was even allowed, especially near a railway. But I thought I'd add that because I've got colour in my hair there, looking very angry. And really, like you've got, when you're doing jobs like this, you want to be doing like the practical stuff. You want to be digging trenches in tractors. You don't want to be sat there staring at all these screens trying to figure out, what's there, what's not. And really, the whole premise of Amplify is like, how can we actually make data like more observable? And as a great example of this, I found this image. Can you actually see? Can anyone see what's in this data? I don't know if you know what it is. You might guess what it is just from the image. Okay. Sorry? Nope. It is. It's a magic eye. I'm not sure if that translates here, though. Like, have you heard of Forrest? Have you heard of a magic eye picture? Yeah. You like cross your eyes and like look through it, and then an image appears. And actually, there's a 0 in there. Hey! Well done. And this is supposed to be a very crude analogy of the problem that we're trying to solve. There is vast amounts of data out there. It's very hard to look at all of it. It's very hard to understand it, comprehend it, and it's just because of the sheer amount of data. So, that applies to specific use cases, like the one I just mentioned. If you've got your own data, quite often you've just got too much to be able to conceptualize it, to visualize it, to think about it. On IPFS, like nobody really knows what's on IPFS. Some indexers are attempting to, solve that problem to a degree, but it doesn't go very far. It usually stops at like a metadata level. Like IPFS search, for example, they're doing a great job of indexing CIDs and attaching metadata about like MIME types potentially and things like that, but then it stops. So we thought, well, can we improve upon that? Can we leverage Bacalhau to attempt to describe this data in a better way? Investigate images, classify things, describe things, so on and so forth. Okay, so in terms of overall goals, so that was the general concept, and then we started to think about, okay, well, how do we actually implement this? So the first sort of goal was to attempt to explain the data that we're seeing in IPFS. We want to not only touch upon MIME types and things like that, we also want to describe like what's in an image, what's in a video. If you've got a structured data set, can you provide summary statistics and other descriptive statistics about that data? We wanted to enrich the data as well. We didn't want to just stop at explaining the data. We wanted to add things to it to make it better. So we're talking about here like reporting on structured data sets, some generic like validation and imputations if you've got missing fields and stuff. Adding additional relevant information if you have like a lat long in a file, like add extra information to say that specific location is a city or a state or so on and so forth. And validation and testing as well. And then finally, the third tenet was enhance. Can we actually improve the data that flows through our system? And initially we've just started off with really simple enhancements like resizing images, resizing videos. But you can imagine all sorts in terms of like augmenting the data and improving the quality and compression and stuff. And I came across this word, Transmogrify. That's got to be the best word in the English dictionary by far. That's what we're trying to do. We're trying to take the input data, transmogrify it, and produce something better than what we found. All right, so given those tenets, then we started designing the thing. Key design decisions. Well, the first one was we wanted to leverage Bacalhau. And this is my beer from after Lisbon last time. This is the Bacalhau beer. Yeah, I'll just leave it there. I just wanted to put a picture of my beer in the presentation, okay? So we're using Bacalhau, and that kind of forced us into, well, not forced us, but it made a lot of decisions easy for us. So, for example, all of our jobs are Docker-based, nice and simple. All of the code is written in Go, because Bacalhau is written in Go. We were trying to make it easier, basically, to maintain moving forward alongside the Bacalhau project. React for the front end. I know that we've got Forrest is an expert React developer now. So well volunteered. One of the first interesting and controversial things, I think, was we kind of knew from the get-go that we didn't just want to have a single job for doing all the things. We wanted to split it up into sort of discretized little chunks of work and then group it together in some kind of graph. And so we thought, well, let's take advantage of a proper graph execution engine like Airflow. But in fact, kind of decided not to do that in the end. Even though Enrico has done some great work on integrating Bacalhau with Airflow, it just kind of we didn't really have too many complex requirements for the actual graph execution. So in the end, I found it easier just to quickly write my own graph executor. It's just a bit of Go. It's obviously not as sophisticated and whatever. And obviously, moving forward, it probably would make sense to refactor that bit of code and use a proper executor. But I think, this is a good point. We only had 8 weeks to do this, and 2 of those weeks we were off for Easter. So this is 6 weeks worth of work. So it's just decisions. And big fan of automating the build and deployment process. Stole a lot of the code from the Bacalhau code base, but also then added a lot of code to auto deploy, CD style deployments. So we don't actually do any manual deploys like we do in Bacalhau, which is a bit painful. So just hit release and you're done. It'll get deployed to production. Based upon some experience I had developing in Bacalhau and working with IPFS, I kind of decided quite early on as well to try and reduce the dependencies in the code base as much as possible. Working with IPFS, the libraries, the Go libraries related to IPFS was a little bit painful, and there's quite a few breaking changes over time. So I kind of decided to keep my requirements and my dependencies as low as possible. I really, in the back-end code, we only depend on Bacalhau, really, and there's a couple of helper things as logging and all the command line stuff, and a little bit for parsing CIDs. Again, on the front end, similar sort of idea, React, and a couple of dependencies there. And, and the main reason why we did that was because, Go people just like to rewrite everything from scratch. Because this is the way. This is literally all you hear on all Go forums everywhere. It's like, why do you have to rewrite your own stuff? Why don't you use libraries? Well, this is the way. So I followed that methodology. We wanted to encapsulate the idea of work. That was quite easy. We've already got the Docker primitives and the Bacalhau primitives to do that. We worked on a very sort of strict but simple input-output interface as well. That was necessary because we knew that we needed to pass data and pass information between the steps in the workflow, and all of the different DAG engines, like Kubeflow, for example. They've got some really good APIs to be able to pass data between them. But for us, we wanted to keep it even simpler than that, especially when we're working with Bacalhau as the execution primitive. We can't really overlay that with too much complexity, and so we stuck to the same primitives that Bacalhau uses, basically the file system and standard in and standard out, and standard error as well. So all of the communication is done through those channels. Is there anything else that I've forgotten there? Oh yeah, no, that's about it. So yeah, let me talk about the architecture of the back end a little bit now. And I've tried to, liven things up with a description of the back end in terms of Lord of the Rings. So on the front end, we've got the UI. Sorry, I keep clicking Enrico's laptop. We've got the wizard. We've got the UI, and it still annoys me even to today. All of the kudos and all of the wizardry goes to the front end guys because they present something that is pretty and usable and whatever, even though there's all this that goes behind it. So I thought that the Gandalf was a good representation of that. That goes into the API server. We've got a couple of Swagger definitions in the repository that are all bundled together, and that forms our API implemented in the code. And this is I've forgotten her name actually, but she's like the head elf dude who, nothing gets through her apart from all of the important stuff. So I thought that was good for the API server. Sorry? That's the one. Thank you. Then we've got the queues, and the queues are necessary because I'll explain in just a minute, but we've got many, many jobs running. It's not just one job at a time. We've got jobs coming in from triggers, which I'll talk about in just a second. We've got jobs coming in from user requests, and so we need to queue up those jobs in order to deal with the demand. We've got two types of queue. We've got a high priority queue and a low priority queue. Could have just had a priority queue, but it was easier just to make two copies. And then we've got Spiegel here with his little low priority queue. This is the guy, I've forgotten his name. Again, you can probably help me here. He's the guy that actually plays. That's the one, Andy. Thank you very much. Do you want to come up here and present this for me? Then we've got the task factory, and this is taking in a config.yaml. It's like a configuration file which Enrico's going to show, and that's where you define your jobs and you define your workflows just in a simple YAML format. This is like the head orc dude because he's the guy that gets stuff done in Lord of the Rings. He has big wars and stuff, so I thought that was good there. We've got another job queue. So one of the early things that we did is we accidentally denial of service attacked Bacalhau by just launching thousands and thousands of jobs. So it's oops, sorry. We'll add an intermediate queue to kind of slow down the job request there. Then we've got the actual executor, and that's the thing that takes the job definition and converts it into something that actually runs the thing to completion. We've got two types of jobs. We've got a Bacalhau job and an internal job. Oh, and yeah, the executor is it Sam Wise? I forget Sam. Yeah, he's the only guy in this film that actually does anything useful. And I'll just jump back up to the triggers momentarily. I was so the triggers are the things that are responsible for listening or watching external things and instantiating job requests. So an example of a trigger is watching, connecting to the IPFS DHT and watching for all of the new CID notifications and submitting them as a new job. Another one could be watching an S3 bucket, or it could be watching a website or something. And all of these things are generating events that are triggering new executions. But I thought, well, what triggers me in Lord of the Rings? And it's actually this guy. Really, really winds me up. It's he's obviously such a good actor, but the character he played in that just winds me up no end. And then we've got the different types of jobs at the end. Nice dwarf man actually doing some real work, and that is Bacalhau. So yeah, hopefully that wasn't too nonsensical. Right, so let's dig into some of the more specific details about these things now. So all of these slides have a little QR code. They take you to the sort of respective code or documentation for the thing that we're talking about. So jobs and workflows. Jobs are a unit of work, and they are represented for now as a Bacalhau-like runnable thing. We mostly use Docker for all of our jobs, but no reason why we couldn't use a WASM job. It should be pretty easy, just hook that in. Specified in the config YAML. If you were to write a new job, then there's a couple of requirements. We've got a little bit of an interface kind of spec doc in the repo. They must operate over all files and directories that are passed into it. So one of the interesting things about CIDs is that there's several different formats, and they're all in common use. The two most common is a raw blob, like CID. So a CID represents a blob of data, comes with zero metadata. So no name, no size, no nothing. It's just a blob. Then you get other standards like car files, which are a directory-like structure that comes with file names and sizes and things like that. So anyway, the way we kind of handle that is by saying, you've basically got it. Your job has to work over all of these things. It has to work over all files, all subdirectories, and if it's a blob as well. So it kind of complicates the code a little bit, but it does just mean that no matter what CID we get, we can just feed that straight into a job. And then on the output side, you've got to write to the output directory. It's like configurable. It doesn't have to be a specific directory, but it has to write to an output directory. All of the metadata should go to standard out, and that's important for predicating jobs. I think Enrico's going to talk a bit more about that. All the messages and log messages go to standard error. And we want to try and retain the structure of the input CID on the output as well. So, for example, if you've got a CID that has an input called file.jpg, we kind of want a structure on the output that has similar naming conventions so people can find it easy to understand. And then we've got the workflows. Workflows are combinations of jobs. So in Amplify at the moment, we typically expect one single workflow. It starts with a root node, and then it sort of fans out from there, working through all of the jobs. But it doesn't have to. You can actually have multiple workflows running on the Amplify in the config. Simple things like must have a unique ID. There's got to be a root. None of that is particularly interesting, to be honest. So there's a couple of patterns that have emerged, though. Obviously, every Bacalhau job results in a new CID, but quite often we run different workflows and we kind of want to merge them back together. So what we do is we run all of these separate Bacalhau jobs, gather all of the CIDs up, and then merge them back together in one final, what we call merge job. So we've got like a list of kind of jobs that we've developed which are kind of like internal, or not internal, but like often used, basically. One of those is a merge job, and that merges everything back together into one single CID. Enrico's got loads of great examples of this later on. Already kind of mentioned triggers a little bit, so maybe skip that. The current examples are the examples that we've got running today. I wanted to listen to the DHT, but of course that meant pulling in all of these dependencies to start a node, to listen to the DHT and things like that. That sounded really hard and really complicated. So I instead leveraged IPFS search. So I'm just querying IPFS search and asking it, what new CIDs have you seen in the last 5 minutes? And that has worked reasonably well, except it looks like they're rate limiting us or blocking us or something. There's something going on, because every now and again, the query works for ages, and then all of a sudden it stops working. So I think whoever, if anyone knows the IPFS search people, sorry, we're hitting your API so much, because I think we are being banned. But oh well, we just keep changing the parameters, and it works again. Then we've got the actual node executions. 2 current implementations of that. We've got a Bacalhau Docker executor, and we've got an internal executor. Some of the jobs that we have running are so simple they don't warrant a Bacalhau execution. So we actually do it in Go. We actually write some Go code, and it just runs in there. Okay, so let's talk about the UI and API aspects. So we've got a couple of different APIs. We've got a REST API, which has both JSON and HTML implementations. You can query the API, and this is what it produces. We also have a nice, pretty UI, because we wanted some of the fame and fortune that comes with being a front-end developer. So let me just see if I can find that now. Here we go. So this is running on amplify.bacalhau.org. This is our hosted version of Amplify. It's doing all of the things that I've described so far. We can have a look at some of the state of the system. This is the execution graph. Unfortunately, I did it a bit wrong, and it kind of looks like a tree rather than a graph. But I promise you, it is a graph. So for example, this merged node at the end, you see it's kind of duplicated across all of them. That is actually just one node. It's just I'm shit at writing code. So yeah, sorry about that. That kind of describes the graph that we currently have. We've also got a rough approximation of showing the types of jobs that we've got. These are all the jobs that we're currently running at the moment. Enrico is going to talk you through some of those because they are really quite cool. What else have we got? We've got the actual queue. So this is a big, long list of all of the items that are currently flowing through Amplify. You can see that there's now lots and lots and lots of pages, and that's because we've submitted lots and lots and lots of jobs. And then we've got the dashboard. And the cool thing about the dashboard is we've started to present a load of high-level metadata about the data that we're processing on. Unfortunately, we totally broke this graph here overnight. So it normally looks like this. So please squint and just imagine the metrics graph looking like this. We're approximately creating about 800-ish new jobs every hour. So that's 800 new CIDs that we're seeing every hour and spinning off jobs. And that results, wrong way around, 100. And that results in about 800 Bacalhau jobs per hour. And that number is limited by our settings. We've basically rate limited based upon the number of Bacalhau jobs that we can produce. Easily configurable, you can easily change that to make it higher or lower. At this moment in time, whenever that was, I can't actually see the time, IPFS search decided to turn us off and ban us again, and I only realized a couple of hours ago, so unfortunately we've got a big period of time where it's dead. We've got, on the left-hand side, content types. So this is, I think I can, let me actually open the main page there. Yeah. Show a bit more. These are all the detected MIME types for all of the data that's flowing through Amplify. So this basically is a good overall picture of the data in IPFS. And number one is JSON data, which is a little bit surprising, but it actually, when you look at it, it's like there's loads of deal files. There's a file which has got a bit of JSON in. It just describes some kind of deal. I don't know if it's a Filecoin deal or a different deal. Loads and loads of that. There's a lot of plain text, but that's a bit confusing actually because the metadata parser that we're using sometimes struggles to detect the real, especially when it's passed in as a blob, like I mentioned earlier. Sometimes you get a blob of text, and you can actually see with your eyes that it's encoded in CSV or something. But the MIME type detector kind of struggles with that a little bit and just says it's just plain text. Lots of binaries, lots of images, HTML, and that's about it. So a surprisingly small number of videos, actually. I didn't expect that to be so low. A little bit of Parquet, but to be honest, I think that's probably Enrico's demos. Yeah, not many PDFs. So kind of a bit surprised about what we found there. What else have we got? Oh, and this is again, I'm kind of spoiling your demo a little bit, Enrico, sorry. But this is for all of the images and videos that's going through IPFS, which isn't a huge amount, but for all that is going through it, what's in those images? And there's lots of people, lots of vases, or vase, sorry, we're in America. I think actually this is a weird one. I think this is an artifact from our test data. I think that's actually coming from my fermenter in my garage, and it's being detected as a vase. Don't know what these other ones are. What else have we got? And we've got, for the text data, oh, sorry, I've broken that now. For the text data, we've also got a really, really cool model, again, spoiling your demo, sorry, that is showing a summary of that text data. This is a bastardized kind of summary of some of that JSON metadata that we were talking about, so it doesn't look great, but that's got some interesting data in there as well. All right, so let's go back to the presentation now. Okay, cracking. So what does this all mean? Well, I think in total we've processed about 150,000 CIDs, and that's resulted in about 750,000 Bacalhau jobs over a space of about 8 weeks. So again, that's all configurable. It's just limited by our rate limiting on Bacalhau. So how can you use Amplify? Okay, I'm going to describe this in the medium of Formula One. I don't think anyone's done this before. This is a new moment. Quite a big Formula One fan. So trying to rank it in terms of like from beginners to pro developers, because there's different ways in which you can use Amplify. And we're going from I collected some statistics about the most successful Formula One teams over all time. And in 4th place was Williams Racing. They've won 114 races since 1978, 2.5 wins per year. And that's probably their most famous car. That's Nigel Mansell's car. Did, surprisingly well, even though now they're kind of a bottom team, which is a bit of a shame. Beginners can use the UI like I just showed you. You can go in and, let me go back again. And you can quite simply submit a job. So it's just a random CID that Enrico has got on his laptop there. I hope it's safe for work. And that's it. You submitted a job. So beginner users can use it like that. If you're an external developer, you're kind of on the third rung of the step. The third most successful F1 team is Paternus, and they're apparently German. Like they've got they're registered in Germany now, but annoyingly, they're not a German team. The factory is still near Oxford. I've been there, visited, it's really cool. They stem from Tyrol, which is like a really, really old team from like the 60s. And they're the guys that produced this 6-wheel Formula One car at the bottom. But since 2010, they've won 125 races. So they are top dogs. Any guesses for number 2? Sorry? Ferrari. Oh, interesting. It is McLaren. Nearly. I've totally forgotten about Amplify. Sorry. The external devs can use the REST API. We've got a nice Swagger API that's all well defined and created. We created the API first, and then we've got tools in the code base that are generating the code based upon the API. So this is the Swagger spec for that. Then, if you want to get a bit more involved, if you want to start hosting your own Amplify instance, then I would recommend using the Docker container. Simple as Docker run, the container, and away you go. McLaren have done surprisingly well. Very old team, 183 wins, 3.2 wins per year, so more than Williams. But I'd just like to point out to Enrico, look at these flags. They're all England, it's all the UK. Who's the top dog? Yeah, you already mentioned it. It's Ferrari. God damn it, it's an Italian team. No. So if you're a super pro, then you can obviously use the code base, just all Go. You can put that in your own. So for example, one thing we've been talking about is potentially placing the Amplify code in the Bacalhau code, actually merging the repositories. And that should be a fairly straightforward thing to do. I don't think there'll be any dependency issues because there's not many there. But there's binaries as well. You can just go to releases. Where's the releases? Somewhere down here. And, I should have just clicked on that one. And there you go. There's all the different binaries for all the different systems. Okay. Once you're using Amplify, how can you extend it? How can you make it better? First one is you can add more jobs. You can add more jobs. Very simple to do. Enrico's going to show you how that works. Second thing you can do is create new workflows to work on new data types, new ways of working. Again, very easy to do. Just add it to the config.yaml. You could add new executor types. So only implemented Bacalhau Docker and internal at the moment. No reason why we couldn't use a local Docker or a WASM Bacalhau or anything else in between. And finally, we could add more triggers. So again, we're only working on IPFS search at the moment. We kind of wanted to spend time in adding triggers for like watching S3 buckets and things like that, but kind of ran out of time, and the IPFS search trigger kind of exercised the system well enough. And yeah, and that's kind of it, really. These are just links to what I've all been talking about. We've got some introductory documentation actually on the Bacalhau website, on the docs.bacalhau.org website. There's a new tab at the bottom, extra projects or something, and well, it's there, related projects and Amplify. So you could go visit that. You can also go and see the source code for the developers. Most of the developer docs are in the docs directory of the code base. And of course, if you want to follow the project, or if you want to show your support, then please add infinity stars to our repository. That would be great. Thank you. Thank you very much. So I don't quite know how you want to do this. Do you want to ask a few questions now? Yeah, okay.
For the, I mean, this is the IPFS version, but do you know what IPNI is?
Yeah.
Have you considered using that too instead of just IPFS?
To
search?
what? Sorry.
To like detect,
to like
to make
watch.
a trigger for new CIDs?
Yeah, that should be a fairly straightforward trigger. Basically, you could watch an IPNI address and then trigger on when it changes or something. But that's a valid idea.
I've got an idea as well. We built Lilypad, which is our FVM bridge. It does all the stuff that Amplify does, but much worse.
Yeah.
So I'm wondering if we could add in like a smart contract trigger and a smart contract executor and have very customizable workflows from FVM to just replace Lilypad with Amplify.
It's a great idea. I mean, so obviously those projects kind of happened around the same time independently and sort of arrived at the same place. So I think what that shows is that this pattern is a valid one, and having a tool to implement that pattern is useful. How you do that? I mean, I think that was basically David's argument as to why it should become part of core Bacalhau. Yeah. Because it is such a necessary pattern to have, and I think I kind of support that. So long-winded way of saying yes.
Yep. Questions?
All right, cool. Well, now we've got some really cool demos showing you some of that in action. So I'm going to hand over now to my colleague, Enrico. Thank you.
Thank you, Phil. That was a great talk. So after this nice primer on Amplify, let's see what the workflows are about. And this is really zooming talk into the config YAML component that Phil introduced to you earlier. And but so again, just quickly, so what the workflows are essentially are the batteries included component that we ship with Amplify. So we say that the aim is essentially to increase utility of data, and we do that by extracting metadata and derivative data according to the metadata detected in the first place. Now, as we said earlier, it was challenging because we need to sort of support different formats, and we've seen that UI already And yeah, one feature is that well, these amplified jobs and these workflows are sort of running sort of in background with next to Bacalhau, in the sense that results will eventually be available. There's no requirement at all to have them, available right away. And at the end of the day, you'll have a CID essentially that contains all of the nice derivative data that we extracted, and that could be potentially used to power maybe an indexing, an index engine, or something like that. Yeah. Also, the config YAML is a part. It's actually like a file in the. It's like a slow-moving part in the code, in the sense that it's in sort of it's part of the code base, and you can update it through pull requests. You can just like submit it and have update workflows in one submission. So let's take a look into what the jobs look like. And these are like the very first part of our configuration. And essentially and starting really from the metadata job, which is like the very first one that runs, and is, as we said, is a Bacalhau job under the hood. And we created a number of custom containers leveraging existing images pulled from the Docker Hub, and just added a little bit of logic around that, but it's very minimal. So as you see, we run a Docker image, and there is a common feature which is actually sort of enforced by the job contract, is that so these jobs are supposed to print out to standard output JSON text that have some meaning for their aim. And in the case of the metadata job, it will output a MIME type. This will be used later on in the control flow slide I'll show you in a minute. And what else? So the job is very simple. Basically, we just added this new entry point, which is a runner script on top of existing images, which it's quite minimal in a way, in the sense that it's going to call the sort of underlying processing binary from the original container, Tika in that case. So we're using within Tika to extract metadata. Traverse the input file tree, and also we'll sort of try to act as a gatekeeper for input and output file extensions that, as we said earlier, whenever that's not available, it's a bit tricky, because your whatever binary will probably refuse to process your image or video file if an extension, file extension is not provided. Not always the case, depends on the program you're running. And in case you need some extra horsepowers, you can also, add CPU and memory, and that will be just passed along to Bacalhau and make your and allocate more resources. So as Phil showed, the job list is comprised of roughly 10 jobs, and this is we built around the initial, the understanding of the available MIME types, the MIME types that have been seen, over the first weeks of when Amplify had been running initially, and we try to sort of craft workflows that tackle the most important ones, such as text or maybe videos or images. And now, so the configuration. So whenever you put, so after you sort of prepare your nice jobs and push your containers to whatever, we'll be using GitHub container registry. You want to put them together into a graph, and this is how it looks like. Let's say everything starts with the metadata node, which runs Tika, fine. And in the case of, so right now I'm just showing like a CSV, like it's the part of the workflow config that pertains to CSV processing. And we have a CSV validation node that, in this case, is just connected to, well, it's just a downstream node. Under hood, this is using a framework called Frictionless to inspect your CSV data and output text or JSON text, whether it's valid or not. But essentially, what matters here in terms of control flow is that Phil came up with this nice idea of predicating over a standard output provided from upstream jobs. How do you do that? So you just add a predicate line to next to your input, and this is essentially running a regex that if validated, so it will run a regex against the metadata node standard output in this case, and so for instance, like if it's CSV text/CSV file, that will pass, and final devalidation will be scheduled for processing, and so on and so on. So what I after the validation regarding CSV, I've also added a profiling node, which is essentially inspecting your CSV data sets and create a report that I'll show later. But these, again, in terms of control flow, will run whether only if the previous node said that it's a valid CSV. So you can imagine that with this predicate primitive, you can come up with fairly simple, but like you have some control over your graph, right? And yeah, so you see this. It's the whole graph, and so it's this showtime now. I didn't dare. I'm not daring to run this stuff live because it takes a little bit of time to process. So I pre-recorded it. Yeah. So that was the manual submission of any CID really to the Bacalhau. Oops. And yeah, so I'm a big fan of The Office TV show. So what I've done is I've uploaded a textual transcript of the first episode ever, and which is just a plain text file, and then I will look into what Amplify outputted, and so let's inspect the metadata. output, and you'll see that indeed there is a content type text plain value there. So if we just walk, so we're just reversing the output, and this is just a second, sorry, that was too fast. So cool. The text, the transcript file is being correctly detected as a text plane, and in my graph I've included a language model that summarizes text, and as you can see, the transcript is being summarized by this model, apparently with a Michael Scott, centered text, which says, "This is my kingdom as far as the eye can see." And yeah, again, so we also have a UI widget that displays the most recently extracted data on the dashboard. So I guess this was the output text that we were expecting to see earlier on the dashboard. But essentially, this is how it looks like. So something more about video. Well, MP4 or MOV files are supported. Again, I've just submitted a MP4 file, and this is Michael Scott really making clear that it doesn't like PowerPoints. It's a very funny scene in the show, in our configuration, we have a couple of nodes that process video files. Initially, there's a very cool YOLO-based object detection node that can actually produce a version of your input video with bounding boxes overlaid, or also will it just crop out. You see, it detected a number of objects. It will also extract image crops out of, some of the frames that it went through. And that's pretty. There's some fun stuff there. On top of that. And on top of that, there's also a, so this is a node that it's capable of resizing video files to a set of, fixed resolution values. I've taken these out of the YouTube default resolution list. Sorry. But so it will also downscale the video for you, and the idea is that, right? So when you have when a CD containing this file is seen, it will right away make available a number of downscale versions of it. So far, so good. I love it. What about structured data? Now there is there's also a workflow that I'm not going to show now, but it will attempt to extract CSV data out of sort of a variety of tabular formats. But here I have something more visual, which is again the Office-centered demo, and this is an IMDb dump of the episodes throughout all seasons. And it's a CSV file. It is a valid CSV file, as we can see here, right? And yeah, so we're also running a profiling node. I don't know if that's the best actually name to describe that, but essentially this is meant to generate this is HTML or JSON report that is very, very useful when you want to explore your data sets. Why? Because it will save you time, and will you don't have to pull up a pandas code and inspect your data set. You'll have you have a bunch of stats pre-calculated for you. For instance, this one I found pretty cool. You can actually inspect alerts and and see that the guest star column is missing most of the times in this data set. Ratings are fairly high, and I agree because I love the show. You also have, no, it doesn't like that. No, sorry. So as trained data scientists, I would love to have these on every data set that I've looked at during EDA. And so in this color plot, you'll see that probably the ratings sort of went down a little bit as towards the end of towards the latest seasons. And I see somebody nodding in the audience, so probably that's agreeable. And last but not least, we also have a workflow that tackles image files. And again, this is doing so for image files. We're doing two things. We're rescaling them to different resolution, different scaling factors. And we'll see like a 50% rescale example. But also leveraging the YOLO container that we're also using for images. This time we could also detect, run object detections, and weirdly enough, Dwight is being detected as a person with a very low confidence. Maybe. Again, this is essentially the Amplify dashboard showing sort of what are the top 10, I think, objects detected. That's all from me. Thank you.
Questions?
Has anyone used this for like a specific application yet? Like for a, I don't know, media site, or just, I don't know.
I think, well, not yet. It's very recent. As we just built it basically in last month or so. But possibly. And also, now, how many CIDs we process? 150K? Yeah. So I think, it will need some time, right, to just, I just have to let it run and, process more data, and we'll take some time till we get enough. I think, eventually, if it sees some, relevant video, you'll have these artifacts created accordingly. So it depends really on what CIDs are being, detected by IPFS search.
Great. Thank you very much, Enrico and Phil.
Thank you.